Thank you very much. I'm sitting because I'm using lots of mouse actions and my knees are not very good anymore. Okay. First things first. After these 14 years, what I have been here, the conclusion first. Number one. Here is no pyramids. Number two, here is no radio. Okay, I promise to start like this, Okay, we go back to the main point. So first things, a really warm thank you, Semir and Evelina, Aidin, everybody here, Semir and your team, for the invitation to come here again after 10 years. My presentation is lasting about 1 hour, something like that, and it's two parts. It's one part is kind of historical thing, and the second part is the thing what has happened sound-wise to me on this trip, during this trip. And here on the front of the table you see the equipments what I have, what all the data what I'm going to show is recorded. And it's a bat sound detector designed to record bat sounds, and then it's normal Zoom 6-track digital recorder, which is used mainly nowadays for film industry and music industry and so on and so on. Then some mic, this mic, what is infrasound mic, is what I'm using for infrasound investigations. And then Slobodan Misdrax designed 3D electromagnetic sensor which has X, Y and Z angles. So X is this, vertical, then horizontal, and then there and back, I call it, But anyway, sorry. The first thing I came here is this picture. There is Richard Hoyle and Sarah Konji. Richard was working here a long time. Sarah was archaeological from Italy. She was working in archaeological manager here or something like that. That was 2010. And then of course I had to go there. Nowadays, was it called Belvedere then?
Yes.
Yeah. And I was very skeptical when I came here first time. The reason why I'm here is actually on this picture, because this is Paolo De Bertolis from Italy. And he invited me to his group, SBRG research group. And he was doing first infrasound tests on the top of the pyramid. And the reason why I'm here, I read his publication in Finland, and I thought, hey, what is this? And this can't be possible. And pyramids in Europe, what the? And okay, then I sent him an email, and I was checking what he's doing. He says, he has some kind of parachute there. No, but he is. He was investigating with his Italian-made combander, which is designed to capture ultrasounds. Raise your hands if somebody doesn't know what is ultrasound. Okay, ultrasound is about 20,000 hertz up, so we can't hear those sounds. And infrasounds are below 20 hertz, so very low sounds. And ultrasounds are very high sounds, and it's the sound is everybody know what is the sound. We hear it every day if we have ears, and also animals are using that to communicate to each other. Bats are using very high frequencies. And for example, elephants are communicating to each other with 10 hertz or 13 hertz or something like that. Here you can see on 2010, and the vegetation on the top of the pyramid was a little bit different than what it's today. And you could see the ground features very well. Oh no, not yet. This was the first. I go back to this Paulos Combrander thing. Why I'm here? I sent him an email, and I said that I'm the sound engineer, music producer, sound designer from Finland, and I've been doing this last 30 years. This thing, and this sounds interesting. Can I propose you something that we should wider the frequency scale and go with the higher sampling rates so we can capture much more accurate data from here, sound-wise. And there's nothing to do yet with the electromagnetism, except the sound is a molecule movement. And Paolo replied me after 3 weeks and said, "Hey, it's great. I send you tickets. We will go there on May, and you are very heartily welcome to our group." Now, I'm still here, and kind of a journey started then for me, and it has been very interesting. I haven't been here connected all the time, but every time when I come here, I feel the same. It's beautiful people. Nice atmosphere. I start to feel the pyramid energy as well, somehow. But as I said, I'm a sound guy, so I want to hear. If I have to lose one side, I would lose, vision. Okay, then I came here, and this guy you probably know. He's Ajmir. He took my camels away. That's an inside joke. But he's now he's a big manager here, and Sam's left hand or right hand sometimes. And he was our tour guide then during that time, our research group. Now then we of course we were introduced every places here. During that time, Ravne Tunnel, Tumulus, Sun Pyramid, Moon. And after one day, I was totally impressed, about the place. Of course, it wasn't so fancy and beautiful what is now. It's a great thing what you have done here during this 10 years what I have been away from here. And we started to do researching with my equipments. Of course, there's Richard Hoyle and Paolo, and we did infra and ultrasound tests in Ravne tunnels, especially infrasound because it's so silent place. You can't actually measure outside infrasounds with the normal microphones because it's full of disturbing extra noises, and on the bass side, it's those extra noises are spoiling all the results. There I am sitting alone, and then I understood that I have to go away because the microphones were capturing my breath, and then I was checking from the spectrogram, what are those, but it was my breathing. Okay. Then 1 year went away. We expanded our equipments. We got the georadar to tunnel, and we were doing, I don't remember where, but we were doing some extra tests also in the surroundings. And here, if you see this thing, I will show you very soon what it is. And then we had oscilloscope also, and we started to investigate also electromagnetic side. And this video will come later. So actually a video can come now. wait a second. This is, you see, this is the so let me be more precise. This structure we found from Ravne tunnel underground, and the video will tell you better what really happened there. So it's where is this? There.
Prova a riprendere un attimo. Questa è la camera, la prima camera, non si vede ancora la camera sotto, adesso la mostro.
Bene.
Si è staccato?
Oh, semplicemente sotto. Finito.
Vai. Perfetto.
Così ingrandisce l'immagine, no?
Vorrei tirare di pazienza.
Ecco. Questa è la prima camera e questa è la seconda camera. Stavolta è venuto è più umido ed è un po' più cancellato la parte inferiore, però guarda come va giù sotto. E non c'è una terza camera.
4 metri.
4 metri.
4
Questa è una tomba e questa è l'altra tomba.
C'è dentro degli elementi di sostegno nella parete, sul bordo. E questo qua dovrebbe essere aria, questa che si vede.
E i corpi sono sospesi a metà.
Teoricamente.
Teoricamente, perché non lo
No,
sappiamo
non so.
ancora, peccato che non scaveranno. Però si vede molto bene, sta venuto bene anche questa.
Sorry?
Can you translate what they are saying?
Perché
I don't speak Italian, but probably
faccio il passaggio sulla sinistra.
she can translate afterwards. Yeah.
E siamo a 4 metri e mezzo qua. Guarda come sotto non c'è nessun'altra camera, guarda, si vede benissimo. Aspetta, questa la faccio la foto un attimo, perché faccio questa perché questa vale la pena, perché questa addirittura è meglio di tutte le altre. Si vede che non c'è altro.
Yeah. This kind of thing happened there. So if you can translate what they said, you know.
Can I take
Yeah, sure.
this one?
Yeah.
Okay, so tell me from the beginning, what was that you saw? You saw the chambers,
Yeah, it was in Ravne tunnel.
and it was in the Ravne tunnel, and they saw these patterns, and they saw bodies.
No. It's we made the ground radar penetrating radar survey,
Okay.
which is here, this yellow machine there.
If you want, you can put it back and then stop it, and I translate every piece.
Ah, okay. All right.
Okay.
All right.
Because I
May
don't
not be necessary to translate every piece.
Do you,
Just repeat what they had on.
just what they thought that it's a tomb.
Simple to
No,
solve.
of course. No, just make conclusion. Can you make it easy? Make it easy.
Okay. There we go.
Questa è la camera, la prima camera,
This
non
is
si
the
vede ancora la
first
camera
room. You
sotto.
cannot see it
La
yet.
mostro.
Bene.
Si è staccato?
Oh, semplicemente
It
sotto.
says that some piece detached, but they are taking it back again. So that's the first room they researched.
Vorrei tirare di pazienza.
They are just fixing it.
Questa è la prima camera.
That's
questa
the
è la
first
seconda
room.
camera.
That's the
Stavolta è
second
venuto
room.
più umido ed è un po' più cancellato la parte
Humidity
inferiore. Però
is
guarda come va
higher.
sotto. Non c'è una terza camera.
There is no third chamber, but it seems to go further.
dentro degli elementi di sostegno nella parete
They
sul
are
bordo.
elements
Dovrebbe essere aria.
from the wall. This must be
I
air,
corpi sono sospesi a metà.
and the bodies are suspended in between. But they don't know what's inside until they don't excavate.
Perché siamo saliti sulla destra. Adesso ti rifaccio il passaggio sulla sinistra, scompare.
Okay, he's looking in the left, and they're gonna be
Siamo
looking
quattro
right.
metri e mezzo. Guarda come sotto non c'è nessun'altra camera, guarda, si vede benissimo. Aspetta, questa la
There's
faccio
no
a foto.
chamber
Ok.
down there.
Faccio questa perché questa vale la pena, perché questa addirittura meglio di tutte le altre. Si vede che non c'è altro.
You will see that there's nothing more there.
Yeah.
Okay.
Okay. Thank you. So that's about it. I was just trying to pass it fast away, but that was, and the result was that Sam was trying to excavate this, but we didn't find anything. That's the thing. Yeah. Okay. Then
But tell them, what was it? What did the georadar actually scan?
I don't know. It's three crosses like this, and I really don't know what it is.
Elon Musk.
Yeah, it's nothing to do with sound, except that there is one anomaly above the thing, what I recorded, but it was just a one sound peak, but I don't know is it related to that.
Do you mind if I just try to explain a little bit more?
Of course, please. Yes, yeah.
Okay, now, in the last 20 years, we've been trying to find possible connection between this level of Ravne tunnels with maybe the level below. And that was the reason why we use a georadar. That, what we were dragging on the floor was a georadar machine from Italian experts. So two of them, brought this machine, they were checking, and the only place where there was potential connection at the lower level was this one right here. All the others would show the compact, continuous materials, sedimentation, nothing. But here, there was clearly something there. So we thought that there was a connection to the lower level, and you heard also their comments that there are something like two bodies hanging, so it could be anything. And then we started digging the same season. However, 15 centimeters below that clay was the water. Water was coming constantly. So we said, okay, now if you try to dig, you're going to have just more and more water. So we said, okay, what we're going to do, we're going to come from the other side and we're going to go deep, avoiding the surface water. So what we did, we actually went through that wall from conglomerate, and after 2 meters, we discovered another tunnel, which was not connected with this one. We came to this other tunnel, and then from this tunnel we went down. We were digging about 2 meters deep. And indeed, we went under that water, which was 15 centimeters from the surface, but we have not found anything. The clay, it was continuous, it was not disturbed, meaning nobody was digging there in the past. But how come we have that very obvious anomaly? Because everybody agreed that it was an anomaly. Now sometimes we have to be aware that there are some things that our senses can see, even our instruments can measure, but maybe it does belong to some other reality or some other dimensions. Maybe there is a connection, but not something that we can use with our physical body. So that was the best that we could come up with.
Yes.
Maybe it was deeper.
Yeah. No, it was meter measurements, very accurate measurements there.
It
So
was
yeah.
exactly from at the ground floor.
Yeah, it's a
Something was there, but not visible to us.
yeah, it's
That's my conclusion.
yeah. That's we and Goran yesterday talk that we are not in this place. We are not amazed anything anymore. Okay. Then we go forward. 2012 we came here and I had the more nice equipments from Finnish Broadcasting Company, and we measured the megahertz radio waves in Ravne tunnel. And for example, this, which shouldn't be possible. That was again some kind of an anomaly. I can't explain how, because radio, there is no phone field, telephone field there. There shouldn't be totally, no radio waves there, but we recorded them there. Then there's one picture about the data sonification, what I call it. The NAS I use is at the same. Also, I'm using it here. I used it here. Now I'm not showing today. I'm not showing my results yet because I do it back in Finland with my files here. And this kind of equipment, there's the tracks and different kind of frequency analyzers, and I can transform the sound frequency up and down. Ultrasound I can make audible by downshifting them, correlation to octaves or something like that. I will show you in the end of my presentation. I do it live with the files what we recorded during this week. So this everything went forward, and our knowledge and understanding expanded. And then of course Goran Marjanovic asked us to his Tesla lab. You saw the pictures 2 nights ago. I was testing my equipments there, and the results were so unbelievable that we started to call this a vacuum cleaner. Okay. Then 2014, then I came here alone, and I had more equipments with me. There is a measuring points what I did then, and also water came as a medium to the. I had the hydrophones and this kind of stuff with me, and that is the equipments what I used then. I still use actually those same things, but a little bit modern modification. There's a Uppsala University. My good friend is Mr. Pettersson, who is developing this ultrasound detector. It's very cheap, 6,000 euros only, and this kind of stuff. It's the thing was that when I came here, that I wanted to scientifically prove that this is something happening here. Like Professor Koronkov yesterday said that science is that somebody can redo it, and also the peer reviewing and this kind of stuff. This is not magic what I'm doing. It's just basic. Those equipments you can go and buy them from the shop, and anybody can do that. Then this methodology what we were using and developing also with Slobodan Mizrak and Paolo De Bertolis, also with Goran. And this is we call it archaeoacoustic standard. You can find it from there on the SB Research Group pages. I'm not starting to explain it more further. But it's basically that we record everything in the same timeline. The infrasound, ultrasound, 3-dimensional electromagnetism, and hydrophones. So we get in one measurement, we get all the results simultaneously. And in the same timeline, so that the time is accurate in every track. So, and the sampling rates is 192 kilohertz, which is very wide. So, and the top top frequency what we can record with this system is about 80,000 hertz. Okay, then more measurements there. First of all, like we know, we have to have a baseline that we are measuring first our equipments, that we are not measuring our equipments and think that this is the final result. So that's my finished baseline with those EM sensors. I had the old one, but this is the new one. The old one is this is the much more better than the old one, because this is the resonance frequencies what are in every result. So this is not an anomaly. And this is the whole spectrum. You can see the visible spectrum is 96,000 hertz in this, 0 to 96,000 hertz. You see the whole electromagnetic spectrum at the same time. So the results then on this 2014 is, this were very peculiar. This is the normal thing, but these are not what is happening. And this is electromagnetism, not sound. This is sound. And as you can see, it's 96,000 hertz and 0. This is accurate from about this point till the end of here. So this is just normal stuff. Nothing is hearable there. Then here is infrasound pressure. As you can see, here is a 0 hertz and this is 192 hertz. So just a fraction of the whole hearable spectrum. So one notable factor is this, that there is, on both things, there is 120 hertz kind of peak. What people, it's, somebody said that it's therapeutical, but I'm not a physicist or doctor. This is a screen capture about the acoustical standard. What I said at the same timeline, we record this is X angle, Y angle, Z angle from the electromagnetic sensor. This is mole sensor, 300 ohms, and this is Brielle chair, two this kind of mics, but two stereo. And then this channel here is that Peterson there. It's output feed. Okay, then to the pyramid of the sun. Before that, one day before, this is recorded from the Pyramid Sunca Hotel, and this is a bat. And I was smoking a cigarette there on the balcony, and I heard it like bats are doing, you know. We can't hear anything else than this. Then I started to record, and I get this. So this is, you know, it doesn't speak with one sound, the bat. It speaks with three sounds simultaneously. And this is kind of a harmonic chord, what they are doing. And this is about 50,000 hertz, this top. So it's very high. We can't hear. We can hear until this point, something like this. Okay, to the plateau. Same analyzing. This is just on the ground floor, where the on plateau where the pyramid starts, and you see a concentration. I called it ultrasound fog, which is from 15 to 30 hertz, 30 kilohertz. And this, mostly this sound is insects and natural phenomena. This is just nothing. This is the machine doesn't record this. This is just an electrical fault. Okay, then we go more further towards the top. So you can see that this ultrasound fog is kind of concentrating or getting thicker. And then when we go up, it's the same thing, same frequencies, but it's very much more solid. But it's not one signal. It's about 10,000 hertz is the bandwidth. So this was happened in 2014. Then we changed to sensors to when we go to electromagnetic side. This is the y-axis, so Earth sky sensor, and this is the results there. These are about 2-minute samples, and there is, the frequencies are there. Then Ravne section, where I used hydrophones and this whole 8 tracks again, this acoustic standard situation. You can see there is it's the same machine than there, and here is the electromagnetic sensor, and here are the 2 microphones. And here is light. There was electricity during that time, but when we made the measurements, Sam cleared the whole tunnel. There was no people except us, and the electricity was cut. So the results were, we can't compare them now, because there is light everywhere and cabling everywhere. So that is very interesting thing. This is, I showed this 2014 already, and this is, like you see, X, Y, Z sensor, hydrophones, 2 hydrophones, and Breuer chair microphones. This is what is interesting about this, that this is simultaneous sparks on the electromagnetic and mechanical wave domain, that they are synchronized, and it's kind of impossible. And I sent these files to Finnish Helsinki University, a guy who is, I don't remember his name now because it was 10 years ago, and he analyzed that, and then he said that there is one paper from year 1969, when, I don't remember the name, but guy has been some testing, is this coherence between mechanical wave and electromagnetism, is it possible? I said, yes, it's possible, but it needs 270 minus Kelvin. And okay, I said, no, yeah, it wasn't so cold yet. And also one interesting feature is that these, if you see this sparks here, these are out of phase. Another is plus, another is minus, but they should be plus and plus. I don't know why it's... Like I said, there's lots of things here in Visoko what I don't understand. Okay, this is a comparison of this upstairs is X angle sensor, and down is hydrophones. The same thing what is in this picture. It shows that this is mechanical wave and this is electromagnetism. These things, what is visible here, should not be there. This is the coherence, unquestionable coherence on the spectrum. This one here is the baseline resonance. Okay, this kind of interesting stuff.
Can you please repeat that last one? What is coherence? What is baseline? What should not be there and why?
This, like I showed before in the finished baseline picture, this thing, what you see in both situations, is normal thing. This is the actual equipment for caused peaks, but this is not.
Above are the EM measurements, below are ultrasound measurements.
Above,
the same frequencies.
yes,
Okay.
in the same timeline, same time, exact, accurate, 192 kilohertz accuracy. And this you can't detect. You can detect those, but that's why I'm using this system, because you can see it. With the oscilloscope, you can't do these kind of things. Or you can, but you know, you have to use different methods to prove that it's actually happening. And the main thing for me is that you know, if I see something unbelievable or something like that, I try to find out why this is happening. Is this, you know, my mistake or something like that? But this is totally, it's unquestionable truth. Okay, this is one no, shit, my English, I'm sorry. That one picture about the ground loop method, what I'm using to investigate different kind of, it can be used for ground testing, what is underground and something like that. But this is interesting because this line here is the basic 50 hertz thing. It's based on ground, this. But these shouldn't be there. And this is happening in Ravne tunnel, in this water section. They shouldn't be here. And I don't know why they are there. So it's harmonic. The place makes harmonics for the ground loop signal, for the 50 hertz. Is Jasper here? Yes. Sorry. Yeah, this is. I think this you have similarities.
Yes.
Somewhere. Yeah. So this is where I stopped then my presentation. There's my not conclusions but theories. And the thing what I'm very happy is this, that you know, possible vortex might be not just happening in the top of the Sun, but around the entire Visoko area, having a diameter 2-3 kilometers. And after this, Richard Hoyle found this, the sacred figures what Semir was introduced us, and I was very happy that that it's also kind of proven from that field and Fibonacci stuff and this kind of things, and Goran's measurements with the angles 60 degrees and this kind of things. So it's nice to be sometimes right, somehow. Yeah. No, this is not. No, that was a consumption. Yes. Okay, this is not stopped yet, but this is for that time. There's lots of Timothy Moon, great people, everybody, still with us most. Okay, so this is the first part of my lecture presentation. Then we go to more interesting stuff. So this is the ERIC software, which is used to manipulate audio files. This thing, actually I'm not going there yet with this thing, but this is interesting because this shows the whole spectrum, and also it shows the continuity of the signals. So, and if we hear, for example, here, this is recorded with the ultrasound machine. It sounds like this. Actually nothing, because you know this is 30,000 hertz, so you shouldn't hear anything. Okay? Yeah, yes, such a you know, that's why I hear this when I'm recording on the field. And actually I can't say anything, you know, what is happening before I analyze it with this. This is people talking. Sonda 12. The hole in the ground, in a pyramid ground. Okay. Then I was planning to do this in the end, but you know I will do it now. So when I do the downshift for the signal, so you see that these are the interesting thing here. So you see that now it goes lower with the spectrum. Now it's 5 kilohertz and you can hear it. Like this. Okay, then a little bit equalization. I'm removing the bass sounds from there, unnecessary bass sounds there. And it's computing that at the moment. Then another from the little bit more away, you can see that its sound goes away. Then I'm cutting the treble side, so higher. I'm trying to find, you know, put this visible, these two things, which are interesting. I can change it like you can see it a little bit better like this. I'm cutting unnecessary high frequencies away from there. And then also from the bottom. So the whole spectrum, what was like this, is now zoomed to that thing and also lowered. So we can listen now how it sounds. Okay, this is 4 kilohertz about this. But to get better results, I lift the gain a little bit. So the volume. You can see what this does. And then a little bit more. I'm not going to overload the signal because that ruins the results. So now you can see that it's higher level. Let's put this a little bit more visible. Like this. So that signal is now 3 octaves down from the original height. And now you hear it much more better. And that is the real pyramid sound. Okay? Let's do it. I normally use on ultrasound thing, I always put 6 octaves down the sound. Now it's 4 octaves down, and you hear the difference. You start to hear the different aspects of the sound. 4 octaves down. I put it as a loop, and then I put it 5 octaves down. And you hear another element in the sound. 5 octaves down, then 6. And if we go here, which is most visible part, I zoom into the signal. Actually, this is a better one here. Oh! Now it starts to, this is talking, you know, people's talk. Computing. This needs a lots of computing capacity from the machine, and it's as you can see here, it's computing. But this sound is, we can't hear it, but it's there. It was there all the time during that recording. What we did. This is for almost 5 minutes is the total time. Now I lost the picture. It's still computing. Okay. So that's about the data sonification, how in real time what is happening. And the initial state of the file was this. Now I show, this is the sonification, but now I show the file itself, how it looks like when you zoom in enough, zoom to it enough. And actually there is two sounds, and Goran was detecting the similar things at the sonda too. So we go, I zoom in to that part, so you start to see visible more the signal. This horizontal, no, vertical lines are just, you know, talking. If we zoom in to this more, here it comes. You start to see why I'm calling that pyramid as a pulsar. And by the way, the similar sounds can be heard from the Cassini spacecraft when they pass Saturn, you know, from NASA. It's online. And one more, we go more near. Now you see why this is taking so long, you know, because I should have a supercomputer. And then, when it has done this, I zoom in time. This is just zoom in spectrum. I zoom to here, like this. So you see, what happened? Sorry. My mistake. I zoom to here. And this is the thing that, you know, you have to be very careful when you analyze them, because now you don't see the sinus signal at all. But when you get the bigger picture, then you see it. So these kind of things belong to this situation. The thing what I'm trying to show about the pulsating, but this didn't do that pulsating thing, because in this signal, what you see there is a periodical, it's a rhythm. And let's see, is this guy going to do that? I'm late, but I'm trying to be very fast, but but this is really, you know, I have never before, during these 14 years, couldn't record this kind of signal from the pyramid. Because this actually shouldn't happen, because normal thing, what we record with that machine is not like this. This is something is really causing this thing.
Question.
Yeah.
So what you were showing was the pyramid sound on archaeological trench number 12B.
12B, yeah.
Below the surface of the pyramid.
Yeah, inside there. You were
And
taking
the
millions of
sound
pictures.
has nothing to do with us people generating
No,
the sound?
no,
Or technical,
no,
like electricity or anything?
no.
So the pyramid creates its own sound?
Yeah,
Just we were able to hear it because you were 5 octaves lower.
yeah, 6 octaves down.
6
Yeah,
octaves down.
and originating 32,000
And
hertz.
the pyramid resonates,
Yeah,
generating this sound.
yes, something is making that, and that's unquestionable in this case.
Have you checked any of the natural hills?
Yes, yes. I can show. You know, this is the same kin from the Belvedere,
Okay.
for example. Oh, sorry about. Here, that's Belvedere. There's no this kind of thing. Just, you know, this is normal stuff, totally normal stuff. This is people talking because you can hear it. And nothing special. Nothing.
Did you try to process it the same way?
Sorry?
Did you try to process this the same way?
Yeah, I don't have. No, I can do it, but you know, I don't have to, because there's nothing special. This is just normal stuff, you know. And we can put then. This is how many files I have been recording during this week, if we get like this. So there's also Semris waterfall, if I can show that. This is your waterfall. And then there's this red dots I'm going to show still, because this is more interesting. This, what I didn't mark, is just normal stuff, nothing special. This is from the Ravne small block. This is the same results than 10 years ago. Then Ravne here, just next to that, in that place there. This is one notable thing in this is this one, this yellow thing, what I call the EM fog, ultrasound fog. Is because this wasn't in Belvedere, but when we come closer to the Pyramid of the Sun, this starts to appear, this EM fog. And it's really weird, because ultrasounds, they progress in the air maximum 30 meters, 20, 30 meters on that frequency. So it's kind of impossible that pyramid could affect here something. And Then another interesting feature from my hotel balcony. It's not this. Just a second. Where does? Oh yeah, it's that. From my hotel balcony. You see, there's a change in ultrasound. This fog, what I call. This is caused. This is time is going like this. I am pointing the very directional microphone away from the pyramid. The pyramid is visible from my balcony like this. Thank you for that, by the way. It's beautiful. Then here I'm turning the mic towards the pyramid. Then I'm turning it away. And then again back, away, back, away, back, and away. So, and this is just not, the yellow thing is just normal town noise. I did this today in the morning. And yeah. Then
is emitting sound.
Sorry?
The pyramid is emitting this sound.
No, you might say that. You know, it's the same thing. This is the same thing that you point the omnidirectional microphone towards the speaker, and if I point it out, the speaker, you know, this. It's as simple as that. Okay. Then more interesting stuff. The sun, the 12, we were kind of thing. Moon yesterday. Jesper got very interesting things there. I was recording 2 to 3 takes actually there, and this is what I got from near. I was away from you guys, about 50 meters towards the sun pyramid. I'm not taking that. Sorry, I do it. Moon 2. Here. So this is. I was amazed to this morning when I opened this file like this. Look. This is this is something else. There is peaks on 50 kilohertz, 70 kilohertz, 100 kilohertz, blah 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 blah, and in kind of I would call it chord in music thing. If I zoom to this and check those old files, you can see it like this. More accurate things. And this is ultrasound, which is on the top of the moon pyramid. And these yellow things are nature, crickets and animals, what are in the forest there. And if we take, this is the highest level. This is 130,000 hertz, which is, nature doesn't do this kind of things. I can be quite sure. If we go,
What chord it is, Heikki?
sorry?
Can you pick up what chord it is? C, D, G?
Not yet. No. Then I have to put it because there is no chords above the 100,000 hertz. You know, it's a C. It can be C 150. You know, but it's also I can put this to visual hearable form, but it takes time. I don't want to take Jasper's time. But the thing what I wanted to show is this about this sound is that it's more the tempo is higher than in sun pyramid and the moon pyramid. But those lines they shouldn't be there. They shouldn't. I don't know what is causing them. And it's. We go. What is the length? Is 33. Yeah. So this is this more detailed picture of that signal. And there is, as you can see, there is pulses, but it's nothing to do with the 50 hertz. And yeah, again something what I don't know. What is this? Then the moon 2, yeah, moon. This is done. I had one more thing to go. This is the electromagnetic samples. This is Ravne K2, the monolith, and these are the XYZ sensor recordings. Just uploading them. So, and you see there is something happening there on K2. Sorry, I'm jumping like this, but you know that I just collected the most important features from the research, and but we can do later on much more interesting results. And this is the thing. I would say that this is an electromagnetic chord on K2 and frequencies about 10,000 hertz. So there's two simultaneous electromagnetic signals which are resonating like this, higher and lower. I don't know what is causing this. And there's this is nothing to do with electricity. The lamps and stuff there. And you electrical engineers explain me this. What is causing this? Not my machine. And this is also recorded with this machine, and I have measured that machine that it doesn't do this. It's just static. The thing what does record what that tape recorder records. It's about this. Sorry. Yeah, for example, this is from the same files from the moon pyramid, from the well, electromagnetism. Nothing. Same sensors, same equipment in the moon pyramid well, compared to this. Or actually, when we go like this, now it's the same scale. We have to always have the same scale when we compare things. So, moon pyramid, K2. Explain me what is happening. I don't know, but and this would be very nice to compare with Zdrav, who was Jesper and Goran's the final results. Then when you and with the same system, so we could say that this is true stuff. As far as I haven't done nothing to this, and also the interesting thing is that this is, you know, when you I have recorded a lot of, you know, normal interferences in this same system, but never I get this kind of harmonics around it, like here. Yeah. No, but hey, then I think I forgot something, but I'm taking too much time now, so I would like to say like this.